In this graph, we can see there are two changes taking place. There's a decrease in price from 7 to 6 and a decrease in price from 4 to 3. We can also see there's an increase in demand from 10 to 11 and 22 to 23. When comparing these two changes, A to B and C to D, we can see the actual values of price change are not equal. But because each value on this graph is decreasing or increasing by 1, the unit difference is equal. We can also see the percent change in price from A to B is smaller than the percent change in price from C to D. We can also see the percent changes in demand from A to B is bigger than the percent change in demand from C to D in this graph. Now, the reason why the demand increases when price goes down is because the law of demand states that when price increases, quantity demand decreases and vice versa. The law of proportionality states that when going down the same value, in this case 1, you will not have the same percent changes because not all values in the percent change ratios are exact. For example, in this case, that would mean that this value and these two values would have to be exactly the same, and that never happens, and therefore you will never get a percent change which comes from the same exact values. Then the PED ratio determines the outcome, determines the PED of the price change. The numerator of the ratio stays the same when comparing two different changes on the graph, which is this graph in this case. The numerator in this graph shows that there is a change of 1 in each change. When doing that, we will see that there is going to be a change of -1 for the numerator in both changes. The denominator, on the other hand, will always be different between the two different PED changes because these values that are given are never ever the same when comparing two different values together. This is ultimately the reason why you never have the same PED, or this is ultimately why you always have a different PED, even if the changing values are the same, even if they all decrease by 2 or 3 or 4 or 5. The denominator, which in this case in PED is the percent change in price, will always be different, therefore making a different PED value. Now, when looking at PED, the total revenue and elasticity of PED, in many cases, or in all cases, when PED is greater than 1, the good is elastic. When it's less than 1, it's inelastic. And when it's equal to 1, it's unit elastic, which is where the maximum total revenue is found, and which is the happy place of a good. Now, we can see that the change 1 is getting closer to elasticity on the demand graph. Although the PED of the first change is 0.3 and the PED of the second change is 0.4, the PED of the change 1 is getting closer to unit elastic because it's getting closer to the middle where unit elasticity is found. Because C to D is moving away from unit elastic, it's becoming more inelastic and therefore decreasing total revenue that can be made. The demand curve shows that at a specific price, the highest total revenue can be made. This is where the highest price for a good is made without losing much money. For example, in order to get unit elasticity, you can have a good that decreases in price from 20 Rand to 10 Rand, and a quantity demand that increases from 30 to 90. When looking for this, you will take the new value for the quantity demand, percent change, over percent change in price. So this would mean that the new value minus the old over the old equals 60 over 30, and that equals 0.5. You then have 10 times 20 over 20 equals negative 10 over 20. That equals negative 0.5, but because it's PED, we work with absolute values. But these two over each other equals 1. This is then unit elasticity, where maximum total revenue is then found. Why does PED change? Well, there are many factors that influence this. For example, you have many substitutes, proportion of income, luxury versus necessity, addictive or not, and time to change. In this case, this graph represents the amount of chocolate bars being sold at a mini cafe in a day. If we're looking at substitutes, let's say another shop opens next door to the shop. Now, if I own the shop, I will then decrease the price so that more people come to my shop when looking for a candy bar. So then, by decreasing the price, your demand will then increase. When looking at proportionality of income, let's say only kids buy at my shop. This means that they don't have as much money as adults do, and therefore let's say they get about 20 rand which they can spend. Now, you can sell less for when selling a candy bar for 7 rand, or you can decrease the price all the way to 3 and then sell 23 in a day because kids like candy, you know. Ultimately also, the reason why PED changes continue is because everything does not stay constant in the real world. People make decisions constantly which affect what happens. So any of the splat factors can change at any point in the day. And therefore, PED will always be changing. When coming back to how and why PED relates to changes in total revenue, because unit elasticity is desired, the price will then change accordingly in order to find unit elasticity. In this case, from 7 to 6 is wanting to reach unit elasticity, but when changing from 4 to 3, it is then past unit elasticity is actually becoming very inelastic. But in this case, from going from 7 to 6, although it has a smaller PED than the second change, it does come closer to the unit elasticity which is desired. Why